Hello everyone, welcome back to our channel. In the last video we talked about the physical nature of matter. We talked about that if we take 100 ml of beaker and we add water in it and we add salt in it, then in between the spaces of particles of water the salt get dissolved in it. Okay, it will get inside it. Now we are going to talk about how small are these particles of matter. So for this we have to do an activity. So activity 1.2, take 2 to 3 crystals of potassium permanganate. We have to take our potassium permanganate, it is a compound, it's a chemical, and dissolve them in 100 ml of water. And we have to dissolve in it 100 ml of water. We have to take 100 ml of water, we have to add 2 to 3 crystals of potassium permanganate. Now take out approximately 10 ml of this solution and put it in 90 ml of clear water. Then again we have to take water 90 ml and we have to take out 10 ml from the previous beaker in it. So 90 ml water and 10 ml previous solution. So total 100 ml. Again take out 10 ml of the solution and put it in another 90 ml of clear water. Then again we have to take 90 ml of water and we have to take out 10 ml from the previous solution. And like this we have to keep diluting the solution like this 5 to 8 times. We have to dilute it. Diluting, it means that we have to add water and water. We need more water and water. Is the water still colored? Like here we can see that its color gets faded. Here it is dark color, here it is light color. So to explain this I will try to give you an example. Okay, glass we take 100 ml of water. 100 ml water, and suppose we add sharbat in it. Okay, 2 ml. Suppose we add 2 ml of sharbat. Okay, we add 2 ml of sharbat. Now if we add the sharbat, suppose we take the red one. If we take red sharbat in it, now this solution, from now we have to take also another beaker. All right, now from in this beaker we have to take here 90 ml water, and from this solution, this whole solution we have to take out 10 ml. Okay, we will take out the 10 ml in this. Okay, now we will add the 10 ml. This is 10 ml solution from the previous one. All right, 10 ml solution. Again we have to repeat the same thing. Again we have to take 90 ml water, again 90 ml water, fresh water. Okay, and then from this again we have to take 10 ml solution. Okay, in this, like this, if we are gonna continue this, then the water is gonna, now the water change, there will be change in the color of the solution. Why? Because suppose if we take a glass of water and we add 2 spoons of sharbat in it, then again from that glass we take 2 spoons and mix it in the another glass of water. By this the color of the sharbat, means red color, will get fade. Similarly, so here also I want to mention that I want to mention that what is diluting and what is concentrated. Dilute means there is more proportion of water. Suppose if there is 90% water and 2 and 10% of another solution. Suppose here we are taking sharbat, okay? So we will say that it is very diluted, it is very light because water is more, okay? And if we talk about concentrated, suppose there is 90% sharbat, you know, very like sweet, and only 10% of water, you know, so it will be like very, if I it will be very like dark, it will be very, ghada, and dilute means it is very like light, okay? So you can remember by this trick, okay? We have to here we have take potassium permanganate, but potassium permanganate means KMnO4. If you have to remember this also, all right? Now, here getting back to this, here what they have told is estimating how small are the particles of matter. Every dilution, though the color becomes light, it is still visible. Now, here we are estimating that how small are the particles, because as diluting we took only 2 to 3 crystals, okay, here, but still color did not fade, okay? And this means that color becomes light, but it's still there. If in a glass of water, if we add 1 spoon of sharbat also, now it is still visible. If we add 2 to 3 drops also, then it is still visible. So what does it mean? That particles are so small that their property we can't see, even if we can't see, but it's still there. This experiment shows that just a few crystals of potassium permanganate can color a large volume of water. It means color of the whole solution. So it means that even a few crystals can color a large volume of water, about 1000. So we conclude that there must be millions of tiny particles in just one crystal of potassium permanganate. So we can say that in the crystals of the 2 3 crystals of permanganate, there were so many millions of tiny particles which just got spread, keep on dividing themselves into smaller and smaller particles. Here the particles got divided equally, okay? They divided into smaller and smaller particles. The same activity can be done using 2 ml of Dettol instead of potassium permanganate. We can also do this activity at home with taking 2 ml of Dettol in a, if we add a Dettol in a bucket also, na, then we get the smell. The smell can be detected even on repetition, even on adding water and water in 2 ml of, suppose we take a bucket, we add water in it, then it added, and then again if even if we add water, even then the smell of Dettol will be there. So this means that the particles are dividing into smaller and smaller particles. So the particles, we can say that the particles of matter are very small. They are small beyond our imagination. Thank you so much.